Personally, with SQL Server replication, I work with different clients on, somewhere around 60 different SQL servers that are using SQL Server replication, and it's a pretty useful feature when it's done right. With replication, there's really three main components. The first one is the publisher, and the publisher, well, the whole metaphor that they use around replication is kind of based around the newspaper and newspaper distribution world, where in newspaper you have publishers who print the paper, those who distribute it and get it out there, and then the subscribers are those who receive the newspaper. With replication, it's very similar. The publisher, though, is the database that is defining what data it wants to share with others. Let's say you've got a database with 1,000 tables in it, but you want to share 6 of those tables with other databases. You can choose to publish 6 of those tables. The publisher can publish tables, it can publish functions, procedures, other objects, and those get copied from one database to another through the different replication strategies that we're going to talk about here in a minute. But the key to understanding the different replication modes is first to understand the components. So the publisher is what's defining the things in a database that are going to be published or shared with another database. Then there's the distributor. The distributor can exist on the publisher, or it can be a standalone SQL server, either way. And the distributor is a middle component that helps take the things from the publisher and get them out to the subscribers. It's sort of the central location that knows what data is being published and what data needs to flow from point A to point B from the publisher to the subscribers over time. And then finally we have the subscriber, and the subscriber is simply the SQL Server database that is receiving data. It's the SQL Server and the database that's receiving data. Things to keep in mind with this is there's a lot of components that go into this, including SQL Server agent jobs. So the publisher and the distributor at a minimum require at least SQL Server Standard Edition, where you can schedule and run agent jobs. You can't use SQL Server Express for your publisher or your distributor. But you can, however, use SQL Express for the subscriber in a number of scenarios. If you have the data, being pushed from the publisher to the subscriber. So there's different types of replication. And first off, there is snapshot replication. There is also transactional replication, and there's merge replication. And these all have very different features and attributes that change or will help you decide which of these replication types is right for your environment. First off, with snapshot replication, that's kind of one of the more basic ones. And the way snapshot replication works is you set up your publisher, and you set it up in a way that you're defining these are the things that I want to be moved from the publisher to the subscriber, and then it's scheduled, so it's just going to take a full copy of those and move them over on a specific time interval. Some people do this where they copy an entire database through snapshot replication once a day. Others may do it once an hour or even once a week, depending on the specific needs. Snapshot replication is great when you don't need the data to be super live or super up to date as it's streaming. Snapshot replication can be used, let's say you're running, let's just use a store as an example. Let's just say you're running a chain of mini marts or convenience stores, and you have your standard product inventory. Well, the product inventory database or tables, there's different parts of it. There's the parts that changing as things are selling, but there's the parts that are fixed catalog that just don't change at all. So for instance, a description of a specific soda pop in that inventory table, that's not going to change very often. And that would be a great one if it's things that are like product catalog that you're having to synchronize from one central location out to multiple stores. Snapshot replication may be great if it's things that don't change frequently, if it's things that you're okay with a day old or an 8-hour old snapshot of that data. It's something that's, once you set it up, it's fully automated, so all that data gets synchronized. Some people, when they hear snapshot replication, they think, well, could I just take a full backup and restore a backup copy of that database over to another server? And yeah, that would be kind of similar to how snapshot replication works. However, snapshot replication in the publisher, you have the ability to define just a subset of the database. So rather than having the entire database being taken over to the other location like you would have with a backup process, you're able to just pick a couple of tables or even some columns out of a couple of tables and have those synchronized to that subscriber. With any of these replication types, you can also have multiple subscribers. So let's say you have a chain of convenience stores and you have 20 convenience stores with one central headquarters. You could have all of that product catalog syncing out to all of those convenience stores from one central location. Product catalog works great for that, but if it's things like actual inventory quantity or things that are actually in stock or out of stock, those are changing frequently and they probably wouldn't work so well with snapshot replication. So snapshot replication is probably the most basic, but it's also a fundamental of the other replication types. For instance, when you set up transactional replication or merge replication, part of initially populating those other databases is similar to snapshot replication, where it takes an initial snapshot and moves that over to the other servers. Okay, so let's take a look at transactional replication. Transactional replication is different from snapshot replication in that it's catching things that are changing throughout the day and then moving those over to the other server on some time interval. Now, when you set up transactional replication, it's very similar to snapshot replication, where you give it tables or columns or subsets of tables that you want to move. You can say, of these 1,000 tables, give me of these 1,000 tables, I want to only replicate 3 of those tables. But if one of those 3 tables has a really fat column that we don't need on the other side, like a varchar max or something like that, we could say, let's just skip that last column that's not needed and take that out of the replication. So it's only going to synchronize part of a table if that's what you choose at that point. The other thing with the different replication types is you can usually specify a where clause. So if you have these 3 tables that you're synchronizing, you've already skipped one column like I just talked about, and let's say you don't want to transfer any archive data that's no longer valid, that may be older than 2 years or something like that. You can put in, it's similar to a where clause, but you put in a filter so it will filter what's being sent across there. So if let's say you have a table with 10 million rows, but only 500,000 of those rows are new or relevant, you could put in a filter there that says copy only those new rows. With transactional replication, you have a log reader, and the way it works is it scans the SQL Server log files, the database log files, so that it can figure out what transactions need to be moved to the other side. Now, that's an important factor here, and how that works is that in snapshot replication, it doesn't need to do that. It just pulls a copy of the data on a specific time interval. With transactional replication, there's a log reader there, and what it's doing is it's scanning your SQL Server logs, figuring out which things need to be caught and moved over to the subscribers, and then it's scripting that out in a way that those can be then transported and then applied or replayed on the subscriber end. With transactional replication, you can control the interval of how often that happens. You may need to have that happen once a minute, or you may need to have it happen once an hour, or it could even be once a day. If you went that long, it would be very similar to snapshot replication because it would be just as stale. But with how often that data gets moved is an important factor in understanding what you're using that subscriber database for. If it's something like you need to know how many are in stock right now to determine if we have to reorder something, for instance, that might be something that transactional replication is used for, and it's set to a very small increment, like maybe every 1 minute it catches what's there and it synchronizes it over to the other side, from the publisher to the distributor and then to the subscriber. Transactional replication, I see a lot of people use this for sort of a warehousing type of, or a reporting type environment. We had one client we worked with where they were running a bunch of reports, and every morning their entire production system bogged down because all these management team people were running reports against that production database and locking it up and making it so that the actual systems that were doing product and sales and movement and all that couldn't hit that database. So what we ended up doing for that client was we set up transactional replication to take a specific set of tables that were needed for reports. We synchronized them through transactional replication from the publisher or the main database where we were having all the contention on, and copied it over to a secondary reporting database. And that way we offloaded all of these big reports that were being run that were really slow and made it so that we could tune that other database optimally for the reporting. So we'd tune the subscriber optimally for the reporting while the publisher only was being used for the production use of what was being used. So people running those reports, bogging the system down every single day, using transactional replication, we were able to give them a copy of that data that reports could be run against. There was one client I worked with years ago where they did a very similar thing, but it was for customer reports rather than internal reports, where their main primary system had a lot of load on it, and when people ran these long reporting queries, it got to a point that those long reporting queries prevented certain things from going into that database. We used transactional replication there. The data was synchronized off to a second database, and that second database was okay to have a little bit of blocking in it because it was just for reporting, and those blocks were not preventing any of the actual transactions from coming into the primary database. A lot of different use cases out there for transactional replication, but really the key around most of the transactional replication use cases is that you have data that's being pushed in one direction and that it needs to happen frequently. For instance, so from one source out to one or more servers, but it's not coming back to those servers, it's just going out. It has to happen more frequently than you'd be able to achieve with snapshot replication. And with transactional replication, you usually set it to keep it fairly up to date within a few minutes. If you had a small enough data set, and if it was something you could say that snapshot replication, that you could resynchronize it every 2 or 3 minutes, usually not feasible with snapshot, but theoretically if you did, the effect would be similar to transactional replication, but the difference is when snapshot replication is being reinitialized, there's a small window where the data is unavailable because it's being replaced, whereas with transactional replication, that's usually only a small window in the beginning of starting to synchronize that data, and once that data is being synchronized, it's just putting it in row by row into the subscribers at that point. It's a great way to go from a central location out to many different locations, going with no data coming back to that center location. Then comes merge replication. And a lot of people who try out merge replication end up pulling their hair out quite a bit. It's one of those things that it's a little bit different, it's a little bit hard to use, but once you get it working, wow, it's so cool. What merge replication does is it's similar to transaction replication, and it takes an initial snapshot and it sends the data out to a number of locations. But with merge replication, you're able to have the data flowing bidirectional, out from a central location, out to a store, and back to that central location again. Now take the convenience store example that we used, and let's say you're tracking actual product inventory and sales, and how many you have in stock at each location. Well, merge replication would be a great use for that, because if one store updates and says, I sold this bottle of soda, for instance, merge replication can sync that back to the central server, that's the publisher, and then out to all of the other stores, so that if you ever get in a position where you're looking for a specific product and somebody says, well, we're out of stock with it here, but we can see it over in store 7, go to that store and you can pick it up there, or we can order it for you. That's a That's a good example of how merge replication could be really, really useful. Merge replication takes a little bit more configuration and setup to make it work, and it's a little bit trickier than the others. With SQL Server Snapshot Replication, I mentioned that all it does is it takes an initial copy of that data and moves it. You don't have to change your table structures in order for that to work. With transactional replication, it does that initial snapshot and then it synchronizes using the transaction log to catch those changes or to catch those things over time. And it does that also without modifying the basic tables that you're using. But with merge replication, it's a little bit different. Merge replication has to modify the tables in some way. First off, for merge replication to work, it has to have a unique identifier that's used to identify each row. So that if 4 different sites are all changing the same row in the database and they're getting synchronized back to the publisher, that unique ID is used in order to do that data sync. So sometimes if you have a unique identifier already in the table, you can use that. But oftentimes with merge replication, it ends up putting on what they call a row GUID or a unique identifier to identify each row. Merge replication it's a way that the data can be changed in many different locations and then synchronized all back to some central location and sorted out as it gets merged back. Now, that process of bringing it back to that central location can cause conflicts. We haven't used the term conflicts or talked about conflicts with snapshot replication or transactional replication because there are none. The data is changing in one place and it's being published to many subscribers. With merge replication, the data is being changed at many subscribers and then being synchronized and brought back to the distributor and the publisher and then synchronized out to all the other subscribers. So you run into the concept of conflicts. Now, there are default conflict resolvers that you can set up where based off of specific rules, it will determine which row will be chosen if 2 people change the same row at 2 different locations, for instance, in a table. There's also a point where occasionally with merge replication, you get conflicts that can't be resolved by the basic rules that are there, and you have to go into the resolve conflicts feature and find those conflicts, review them manually, and decide as you go through the list which one after which one are you going to accept on each of the different conflicts. That's something that oftentimes I end up writing a script for because I don't like to do that on an hourly basis. But even if you're scripting it, there can be some things that you need to occasionally review and figure out which row is the right winner on that merge conflict. With that, with merge replication, like with transactional replication, you control the time interval of how often it's going to synchronize its data. If you have a server and you tell it to synchronize the data every 1 minute, what it's going to do is every single minute it's going to go and connect to that from the publisher out to the subscriber and say, is there anything that's changed or anything new you need? And it's going to send any new rows out, any changed rows out, and bring back any changes from the subscriber. Let's say then that's a convenience store and that convenience store loses their internet connection for an hour. They're still fine to work offline for an hour or 2 or even a day sometimes. And then what happens when they come back online, it tries to sync up all of those changes or all of those rows that had been changed at that location, sync it back to the central location. Now, one of the keys here is to reducing the conflicts is reducing the time frame of how often that data is going to be synced. In the example of being offline for 6 hours or 8 hours or a day, yeah, maybe you don't have a lot of control over that if you lose your internet connection. That's okay. It'll do its best to sync up when you're done. But on a regular basis, if you had the choice of saying synchronize these changes every 1 minute or synchronize them every 20 minutes, if you were synchronizing those changes every 1 minute, you're sending back and forth lots and lots of small changes rather than big batches, big sets of changes. And the sooner that a change can get pushed back to that central publisher and then pushed out to all the other subscribers, the less likely you are going to have a conflict. There's been systems I've worked on where we were running into all kinds of conflicts because the data was synchronizing every 10 minutes. And that gave enough time for a person at one location to change the data when a person at the other location changed it and then cause it to conflict. What we did is we changed that from every 10 minutes down to every 1 minute, and more than 99% of the conflicts were eliminated just by doing it more frequently. So with merge replication, you want to make sure that you're synchronizing it often if you have lots of changes going on at different locations. The other thing to keep in mind with merge replication, I mentioned that there are changes to the tables. There's usually a row GUID that's put in there, or a unique identifier to identify every row. But merge replication also works by putting triggers on the tables. Generally, you have triggers that are going to catch, I think there's 2 or 3 triggers that get put there to be able to catch any type of changes and then track those changes, and that's how SQL Server and replication knows what has to be sent back from each of those publishers back to the subscriber, or what needs to be sent from the subscriber out to the... I said that backwards. That's how SQL Server knows what's going to be sent from all of the subscribers back to the publisher, or from the publisher out to the subscriber, is that it has a bunch of triggers on all of the tables that are being replicated, so it can know when things are changing and what needs to be distributed, updated, or sent back and forth. Each one of those 3 replication types, whether it's snapshot, transactional, or merge replication, they all have specific use cases, and it's best that if you're going to use replication that you understand them all, so you can make the right decisions as to which one is best for your environment. Next, I want to talk a little bit about push versus pull subscriptions. This is one of those things that it's pretty simple, but it can be overwhelming if you don't have the details. If you have pull subscriptions, it means that each subscriber has their own SQL Server agent that's running, and all the processes to go and figure out, does it need more information, are being run on that subscriber. And the subscriber runs on a SQL Server agent task. It then reaches out to the publisher and the distributor and says, give me the new information. Or in the event of merge replication, it reaches out and it sends its information back to that central location. Now, push subscriptions mean that all the SQL Server agent jobs are being run on the publisher rather than on the subscriber. And that's how you can get away with different replication types in having subscribers that run SQL Server Express with no agent, is you set up push subscriptions where you have a central publisher that's running SQL Server Standard or Enterprise, and then it does all of the work of pushing the data out. And when I say all the work, it basically has a SQL Server agent job that reaches out to each of those subscribers and says, do your thing to synchronize the data at this point. And the amount of work that's actually being done is pretty much the same on either end, whether it's push versus pull. The only real difference is where is the SQL Server agent job that's triggering those events in order to be able to get that data moved from one location to another. Okay, moving down the list here. So far, going through this session with SQL Server replication, we've covered a lot of the basics around publisher, distributor, and subscriber. We've covered snapshot replication, which is like a one-time copy. I shouldn't say one time, but a full copy of the entire data set that you're moving that is set up to be moved on a regular schedule. There's transactional replication, which does that initial snapshot and then scans the transaction log to know when things are changing in order to send more information out. And then there's merge replication, which does the initial snapshot, very similar to snapshot replication, and then it uses triggers to catch what is changing on each database in order to be able to know what it needs to synchronize one way or another. And then it has the issue of conflicts that have to be resolved. We covered push versus pull replication or subscriptions and where the jobs are being run that move the data.